For years, us PC nerds have loved overclocking graphics cards in order to maximize performance. But these days, the graphics card makers seem to have squeezed out all that extra performance themselves thanks to the turbo and boosting algorithms. So, what can you do now to squeeze out more from your gear? Well, how about making it more efficient? In this video, I want to tell you about undervolting and show you how you can do it to your own GPU. So, let's get started. Overclocking a graphics card is several generations ago. The new name of the game is efficiency. Undervolting allows the graphics card to run more efficiently and pushes its capabilities in order to target one of two different goals. You can either simply keep the performance about the same while using even less power, which allows it to run cooler and use less power, or you can find additional clock rate headroom for your GPU core now that you've reduced the power requirements to hit the stock clocks. Well, doing this is fairly easy with the ability to lower the voltage frequency targets built into programs like MSI Afterburner, EVGA Precision X, or Wattman within the Radeon settings software. For this video, I'm going to show you how to do this using what has, according to the Steam Hardware Survey, turned into one of the fastest adopted modern GPUs, the GeForce RTX 3070. I'll be using a Founders Edition version on my test bench that features a Ryzen 7 5800X, 32GB of DDR4 3600, and a PCIe Gen 4.0 NVMe SSD. But you can overclock your graphics card on almost any modern system, so none of these details are terribly relevant other than you knowing what system I'm using. That's because we're focused much more on the results using the PCAT system for monitoring power and performance. Now, PCAT is the power capture analysis tool that NVIDIA released some time ago that allows me to isolate the graphics card power draw from the entire system. It also allows me to capture PCIe connection power as well, so I have an actually accurate picture of the power the GPU is pulling under use and even while at idle. With this setup, I'll be trying out both goals. One test for maximizing efficiency, meaning maintaining performance while reducing power, thermals, and noise, and the other test for a traditional overclock to see how the old school way of doing things goes. Now, the process of undervolting is rather easy. For this example, I'm using my preferred software, MSI Afterburner, and this is how I do it. Once Afterburner opens, hit Ctrl F to bring up the voltage frequency curve editor to see what changes are taking place. Now, bringing up the specs of the particular GPU, I can see that its reference boost clock is 1730 MHz. So I want to drop the voltage curve in order to pull back to the reference. So then I go to the core clock slider and I pull the clock rate down to about 290 to 300 MHz below stock, which drops the entire voltage curve, but with it ultimately reduces the top end boosting speed so that I now have control of that. The amount to drop will change depending on which GPU you have, so be sure to check the product page or use a program like GPU-Z in order to find that reference boost target. Now that I've leveled things off to stock, I want to control when and how far it boosts myself. To do that, I move back over to the voltage frequency curve editor and pick a plot point on that curve, typically between 850 millivolts and 950 millivolts. And this is mostly an arbitrary number, but I've not found a single GPU that wouldn't hit the rated clock boost at around 950 millivolts. So that should be a good starting point. So I'll click on 950 millivolt and raise the frequency dot on that voltage up to around the stock operating frequency, which in this case is just over 1900 megahertz. I recommend using the up arrow key to do this, as dragging the mouse pointer is wildly inaccurate. And when doing this, you're telling the GPU to target a specific voltage at the given frequency rather than letting it continue on past that point. Now, you'll typically be locked into that frequency under load if you've hit that sweet spot and won't see the core clock jump around. Next is to determine whether the GPU is stable at those settings, meaning your games won't lock up or crash to the desktop. I recommend using some of your more stressful games in your own in order to test against it, because if it's stable there, then it's a good chance it'll be stable in every other game. Even better, use games that have built-in benchmarks, as this allows you to track changes in real time. Once things seem stable, you have the option of going lower on the voltage for the same clocks or increasing the clock rate to find your sweet spot. If you wondered how aggressive you should move on the voltages that you test, I personally recommend moving in 25 milliwatt increments until you find a crash. Then I go back to the last stable setting. So essentially, you can target better performance at lower power draw and heat output, or you can sacrifice a little bit of performance and see just how low you can go on power and thermals. After each setting change, it's good to go back into the same benchmark and run them against to make sure things are stable, and you can see how your settings have affected the performance and thermals. You need a bit of patience while doing this dance of setting changes and testing stability, but it can quickly become a fun game in itself. And don't worry, with undervolting, there's little to no risk of pushing things too far and breaking anything, since you'll just crash from not having enough power to run the GPU rather than overdoing it. It's kind of like starving an engine of fuel. In order to highlight the results of my own testing, I used Assassin's Creed Valhalla as an example, which was tested using the built-in benchmark at 1080p very high settings. The stock core clock on my RTX 3070 is 1965 MHz, which is quite respectable. First, I used MSI Afterburner to do a traditional overclock and push the power limit to plus 100, and the core clock to plus 80, and the memory to plus 1000. This overclock resulted in a core clock of 2048 MHz on the core. Then I used Afterburner to undervolt, and this was a fun one. So I set the core clock to hit 1920 MHz, but at 925 millivolts. Stock was about 1965 at 1125 millivolts. But I also was able to push the memory by plus 1000 offset. Now this basically resulted in a locked 1920 MHz throughout the duration of my testing. But how did that fare in performance? Well, the combination of the core undervolt and the memory overclock resulted in the performance being within the margin of error, which is a very solid result. The overclock performance gave a bit of a boost in performance as expected, but at what cost? See, that's the interesting part here with these power-hungry big boys. Sure, we got more performance when overclocked, but the power draw of these cards is wild. And if you're truly able to isolate the GPU and see what's going on, well, see this? The stock settings resulted in an average of just over 180 watts of power consumption with the overclock settings, which shows it being power limited by the card. If you had a beefed up version of the RTX 3070, then you could likely push this even higher. But the money here is on the Undervolt, aiming for the same performance as the stock settings, but with a 44 watt reduction. As far as percentages goes, we're looking at a 24% decrease in power consumption. Not only does this result in lower power consumption, but also an easier to cool GPU, because you're now working with cooling even less wattage. Now for the Founders Edition, it didn't move the needle terribly in terms of thermals as we went from 64 degrees Celsius down to 61 degrees Celsius, but that's with the stock fan curve, meaning it didn't have to spool up as much and was audibly quieter. All around, undervolting seems like a winning move. So if it's such a win, why isn't it just the way things are? Well, it's because neither I nor the GPU manufacturers can guarantee you will have the same results. It's like with overclocking. There is a silicon lottery that comes with it. And just like with overclocking, anything that modifies the stock values can introduce instability. What works today may not work after the next driver update, and thanks to the BIOS locks on modern graphics cards, you'll have to run third-party software to do this and hope for the best. Well, the exception there being the Radeon cards, which you can use the Radeon software, but the point still stands. It's a software solution, not a permanent hardware shift. And once again, if it's stable in one game, that doesn't mean it's going to be stable in every game. So I personally recommend trying it with the most intense games that you play. I mean, like we all know, a game like Forza Horizon 5 is much easier to run than a game like Hitman 3. So test with the tougher game, because you don't want to dial in your GPU on the Forza settings and then crash the moment you open up Hitman 3, do you? Well, should you do it? Honestly, if you're comfortable tinkering within software and don't mind frequent restarting until you dialed in that perfect voltage and frequency combination, then yeah, I think most people should be willing to give this a try. It's a software modification anyway, so it's easy to undo, and you're going down in voltage required, so burning up stuff is basically out of the question. What you do have to gain from it is a quieter, cooler, and more efficient running graphics cards. Now, as I leave you, I want to know, have you done this? Will you do this? Or do you just do like most and let things roll by default and let your graphics card do its thing? If you enjoyed this video, let me know by hitting the thumbs up, and make sure you're subscribed here at PCWorld for even more PC hardware and software goodness.